Happy to be back for day 2 of Advent of Code in FStar. FStar is a dependently typed programming language. It lets you write code and prove its correctness at the same time. Before we get into day 2, and we've got a few minutes, I just wanted to circle back to day 1, but thanks to Eric Wastel and the entire team running Advent of Code, and to my employer, Akita Software, that's a sponsor of Advent of Code this year. So we've got about 5 minutes before the next puzzle drops. So yesterday, for part 2 of the problem, we had to compute a rolling window. And so I wrote this version, which was tail recursive, but it was hard to prove properties about it. I eventually managed to prove a, a theorem about its length, but I was not able to really come up with a way of proving that it met the specification, that it was in fact a rolling window. And so I realized today that it would probably have gone better if I'd, skipped the optimization and just written the non-tail recursive version, which I'm putting on the screen here. And that turned out to be the case, that when the function's written this way, then the two lemmas I was trying to prove become basically just trivial exercises in induction. So, proving that the rolling window has the same length is just trivial induction. The base case, the inductive step, proving that each element of the output is the sum of the corresponding 3 elements from the input is also trivial. We just have to state that basically we only have to state that we're using the inductive hypothesis. And FStar throws everything to the solver, and it can figure out that, okay, if that is true, if we take that is given, then the case for n follows immediately from that. It imports the definitions of everything I use here into the Z3 solver, and the Z3 solver, once I give it this hint, is able to say, okay, I can use that to prove what you said was true here. So this is a much better demonstration of what Z3 can do than the sort of frustrating version of trying to do this in reverse, where one list is getting shorter and the other list is getting stronger. So we could probably prove that this non-tail recursive version is equal to the tail recursive version, and then we get, the properties we proved in the easy way here. So something to keep in mind as we go forward. Sometimes the easier version, I'm not even sure it's less efficient. I'm not an OCaml expert, so I don't know if OCaml automatically converts things into proper tail recursive form or not. But I think the lesson is, if we're going to prove properties, we should write the simplest version of what we're trying to do, and then maybe worry about it optimizing it later if it doesn't work. For the first few days of Advent of Code, that should be good enough. So I've got everything set up here. We've got about 2 minutes to go. Thank you, Robin. My time. Oops. My time. I'm not aiming for fast. I gave up on fast a few years ago. People are really very good at writing code quickly, much better than I am. Oops, that's not what I wanted. So yes, I was 5,809th to solve part 1, and then I lost considerable time solving part 2 and was rank 9532. So All right. Got about a minute left. I'll put up the introductory page about F-star again. It's a general purpose functional programming language with effects. So you can simulate imperative programs as well as functional programs. I mean, write imperative programs and prove properties about them as well. I haven't tried extracting anything but OCaml. The wiki says F# is broken. C uses this whole subset of F* called low-star that's got this whole other tutorial, and I haven't looked at it, let alone the WASM or ASM stuff. But the main usage is Project Everest, which is building a HBS stack that is provably correct, which I think is a good thing to have. All right. Oh, I'm so sorry. Oh, oh noes. I am. Phooey. Okay, you didn't see all my. Okay, you didn't see all my struggles here. All right, so we defined a reference, a couple of reference types to hold our depth. We defined we defined forward, and we put preconditions on it. We said the heap, the set of references has to contain horizontal, and we ensured that forward increases the value of horizontal and modifies only that. So if we tried modifying the depth, then it wouldn't type check anymore. And say, no, I can't prove that what you specified is true. This is what I get from trying to be fancy and have an introductory screen. All right. All right, let's run the example. Let's copy the make file from day one. Oh, I did this yesterday too. We actually have to execute that function. All right, is 150 what they say? Yes. All right, now let's vacate. Let's import the real problem and put this prefix in front of it. All right, file. All right, so we've basically built a little domain-specific language here. And this should be exciting. How long does it take to verify all those function calls? The solver getting a good workout. So it's F* churning away. It's not making a lot of calls to Z3 though. At least not long enough to show up. So as long as it takes less time for it to compile, it's using 4 giga. All right, there's some calls to Z3. As long as it's using more, it takes less time for it to compile than for me to write a parser. It's a win. I've run into this problem with Go. I for a side project I tried to create a very large literal, and the Go compiler is not happy making very large literals. I've got my office toy here, Gene. Gene gave everybody at the company one of these for a company. Are we done? We're done. Huh. Okay. Unknown assertion is probably it ran out of time. So we'll bump this up. Set options Z3 R limit, and we'll give it 5 minutes? 300 seconds. Yeah, it will only run the Z3 solver would run for a long time if you let it. But the R limit is a resource limit that's the number of seconds on a reference laptop. Maybe I should start writing the parser while this is working. I should run with the query stats on. So I could see how long it takes to do each of these steps. I don't know if it's possible to turn the type checking off for a particular function and just omit code from it. That would be interesting to find out. I don't think I've seen anything like that in the reference. Oh, all that, I forgot to switch the functions. Well, at least we know it type checks now. What do I even call this? So yes, the FStar team likes saying, "Oh, it's for building domain-specific languages in," except they can't be very large programs in your domain-specific language. There's a bunch of tips and tricks on the wiki for breaking up your big program into little programs. And so one of the things we could do if this refused to work is just chop our big function that's a big Z3 query into littler functions, which would presumably be easier on Z3. We could get it to dump what it's sending, and that would be pretty amusing for this ginormous function, I think. the queries to Z3 are basically the form, is there a counterexample to this, the proof basically that this program is the type it says. All right, we got an answer. Let's see how we're doing after only 35 minutes. All right. This is actually very similar to last year's problem. All right, down increases your aim, up decreases your aim. All right, let's copy that over. And we'll comment that out until we're actually ready to run it. All right, so now we've got an aim. So forward aim multiplied by z. So we don't know whether the aim is always positive. I would expect that it is, but proving it is probably out of the scope of this. So we need to contain horizontal and aim. We need to modify, I don't know what the, let's see if there's anything near only. We need to start the background process before we can start looking things up interactively. So it's a set. Okay, we can make sets. How do we make sets? We can union and singleton. Okay, let's, all right, so let, modifies set dot union set dot singleton. All right, screw it. We're writing a helper function. All right, let two element set of some type, which it infers. The pound means infer the type for me, please. You can infer things other than types like integers. On x2, and we get a set of type A. Equals set dot union. set dot singleton x1, set dot singleton x2. That way I don't have to figure out what the we made the subprocess unhappy with us. This is my least favorite features. If you restart, then it starts complaining about syntax errors, and it didn't before. Okay, this can't work for any type. It can only work for types with equality. Like that. There we go. All right. So forward. So modifies the 2-element set horizontal. Oh, that was premature. We only modify. No, I was right. 2-element set of horizontal and aim. So depth is equal to depth plus aim. Is that correct? Increases your depth by your aim multiplied by x. Up. All right. So we'll do the same thing here. Contains modifies your depth. Oh, well, finally. All right, and the aim increases, so it's bigger in the heap afterwards. All right, aim plus D, and then we'll just copy paste that up. Hello. I'm being rated. I don't know what that means. I'm a Twitch newbie. I think the raters are going to be very surprised to be finding that we're writing proofs in for Advent of Code rather than playing. Oh, I forgot the semicolons. Playing a video game, which is what I plan to do once we're done, but not on the stream. All right. Int is not. Why is it back to asking for? I solved this problem in part 1. I've already forgotten what I did. Expects a net. All right. adder of R. All right. All right. So modifies. Sure. We'll just add another type here. So okay, so this now needs to be a state, have the stateful effect. And we need to parenthesize that, which is a mistake I frequently. Okay, it says the effects are not compatible. So the set union is a ghost total. All right, we'll back that out and we'll just do it the we'll try this way, even though it pains me. Still no guarantee that that works. All right, modify, there we go. Oh, fat fingered that, all right. All right, which part of this can't it prove? Is it the first part? Or the second part? This is the second part, I guess. Where's the syntax error here? Oh, not enough parentheses. All right. So it can improve that part. So why is this giving us trouble as per the conjunction when it was true in the simpler version? Did we screw things up? No, we still got d is greater than 0. Okay. Well, learning experience for me. All right, let's take. All right, so we can prove it without this. So somehow it's the conjunction of these that causes us problems. But why should that be? All right, let's see if we can. Let's see if we can take a look at what it knows. So search by tactic true and just something to print out. State. All right, so it knows. It knows set H10 horizontal. H1's okay. That's our H1. The new heap. Well, let's try proving the stronger condition. That's very odd. The absolute mystery of the language is engaging weirdly. I feel the same way. Uh, it's very rough around the edges. It's been a research language for quite some years. Two of my coworkers at Akita Software both worked on it while interns at Microsoft Research. I'm really puzzled here. All right. Is there something special I have to do when sequencing two operations? I don't know. I don't know what to try next. I can try dumb stuff. I mean, changing the order of operations should not make any difference. Is Gene on saying add more gas? It's taking a while, so the solver is working pretty hard at it. All right, I'm gonna solve that mystery another time. I guess I don't know what more to do about it now. All right, we gotta fix this. This is the dumbest thing ever. There's got to be a better way to do this part too. Is it gonna complain about this too? That's just very unfortunate. Am I not supposed to write a function that does more than one thing? There are a bunch of examples to look at, but they're usually pretty hard to. Okay, what if I do? No, let's just syntactic sugar for a function. I was thinking, can I combine them with and? I'm very disappointed. I may ask for help on this one from the Zulip channel. All right, let's see if our example works. Is everything still compiled down to the end? Oh, no. Oh, our precondition was violated. We didn't have aim in the heap already. All right. All right. 1050. Is that? No. We're wrong. Well, maybe F-star was finding a bug. Okay. Down increases your aim, up decreases your aim. Well, one of the downsides is we don't have a debugger, so we can't follow this step by step and see where we go wrong. We'll have to do it step at a. We'll have to do printf debugging. All right. Gosh, I really wish I could prove what my bug was. But since I couldn't even prove the basic things about it, well, these were wrong anyway. Okay. That works. Why did it start working? I don't know. I guess that in that case, because my specification was wrong. Okay. So those ones go the right direction. Hurrah. So let's make this an an ML function, and let state print strings. Okay, so we want horizontal depth and aim. Horizontal depth and aim. Oh no. The problem with ML is anything can happen. And so it says, what if something did happen? What if you deleted it from the heap? All right, well, we'll do this just a couple steps at a time, I guess. Okay, what's going on here? Maybe I didn't save it. Okay. There is some way to run the commands from Emacs, but I haven't figured that out yet. All right, we think. Okay, that's right. So your depth increases by 40, and it was at 5, so it's at 45. Okay. Oh, horizontal by depth. Okay. That's 60. Oh, our aim is 10. I'm doing something very strong. It's very wrong. Hi, Eric. Yes, I am from Egan. I've lived here since I moved back from California in 2004. I've been working remotely for California-based companies ever since then. Wow. All right, I gotta be doing something very simple wrong here. And I can't think what additional property I can check to find it. I mean, it's gotta be, is this I keep going back to this thing that should still be true. It thinks it's not true. All right. Anyway, so where did we go wrong? Just wait for another 20 minutes. Thanks for swinging by, Eric, and thanks for organizing Advent to Code. I'm been happy to do it for several years since since the first year. Not sure. Well, my star count has gone down as I've tried other languages I'm less familiar with. Doing it in Python was pretty easy, and doing it in Rust was okay. But when I switched to Pi last year, that was a disaster. And this is not shaping up very well either. All right. So right before the forward, our aim is 10. Depth is 50. Okay. All right. That's the problem. Is I didn't read carefully enough. Up and down only affect your aim. So the specification was wrong because I didn't read carefully enough. So let's fix that. Copy it to down. All right. No amount of type checking can help you if you get the model wrong. All right, so let's is that the complete example? Or two, yes. All right. Stray semicolon cannot have an empty statement in F star. I kind of wish you did, but got it. I don't know. How do you guys feel about All right, there's 900. All right, let's re-enable this monster function. And did we already add aim? We did. All right. Swap it in. Wait for it to compile. I was gonna do. All right, let's do that in another tab. I was gonna say we could run a second compilation with all the profiling output, but the compiler's only up to 3 gig. Must not be done yet. The other day, the Emacs mode had gone wild, and I had a 20 gig a 20 gig Emacs process. All right, finally gave all that to Z3, which is checking the very trivial properties, or at least the non-trivial properties over and over again. Yeah, I don't know how long I'm going to get away with not parsing the input. This is pretty bad. All right, let's try it out. Let's copy the whole thing and try it out. Hurrah! Right, how long did it take us? Me, I should say. About as long as yesterday. Oh well. So why won't our condition here work? This is really bugging me. Because so we know that if we don't modify the depth, then it's fine. So somehow it can't prove that that's the case, but oops. Let's see, it's op colon equals. So it should know that the heaps are equal. All right, what does it say? It says if we select R from the heap. Oh, it's the I don't understand. This is not just a heap, it's a pre-order heap, and I don't understand what the pre-order does. And I don't think there's anything in monotonic heap that explains it, as is fairly standard. So I don't know what the pre-order attached to the heap actually does, but this is the trivial. This is for the normal heap, this is the discrete pre-order. So this is basically equals. But maybe I need to. Okay, but this is okay. So the heap contains the reference. Sure. We modified the reference. Okay. What is equal domain? Oops. I don't even see where it's defined. That must be an interface. Okay, this says this is the things that are in one heap are in the other heap. Okay, that makes sense, although I'm not sure of. And it says All right, can we all right, let's check it. So let old horizontal equals horizontal in okay. Let's assert that horizontal still equals old horizontal. Okay, the assertion is true, but that's not good enough. All right. So assert horizontal is now greater than the old horizontal. Spare typo. All right, that assertion holds, and it's still not enough. I don't know. I am defeated. I don't know what else to do. I mean, we looked at it with the tactic and saw the equality. I guess I'm just gonna. Call it a night. Well, thank you everybody for showing up. If there are any questions in the chat, I realize that I'm not very attentive to the chat. I need a co-host to keep an eye on the screen. They're too far apart, or I need to figure out how to get the things to show up on the other screen. Hopefully tomorrow I will remember to switch switch screens right away instead of just my smiling face for the first 20 minutes. All right. Yes, this is the Akita Software logo. Akita Software is a sponsor of Advent of Code this year, and we're hiring. Check us out. There's a link in the screen to our open jobs. If you like working with geeks like me, the other people are also geeks, although with a slightly different flavor. Good night. Happy Advent.